Alright, hi everybody, welcome back. So today we will continue to talk about sessions 8.3 and then homework 8.3 and quiz 3 is due on Wednesday. And then we'll go over the quiz on Friday. You received my email about the study session this Friday from 3:10 to 5 p.m. in the Snyder 161. The classroom next to this is the classroom. Yeah, 161. This is the classroom. Okay, so I hope you can start working on your practice exams, and then you can come to the study session on Friday, ask me questions, and also you can do a practice exam 2 or 3 times. Okay, and this week I hope to see you more often in my office hours. You know, the actual exam and the practice exam are similar, right? So you're gonna solve those problems and try it a couple times, and also change the trig functions, because in the practice exam, if I ask you sine, then your actual exam might be cosine, tangent, secant, cosecant, cotangent, right? So yeah. Okay, so let's continue on sessions 8.3. So last time we talked about the inverse trig function, and we also talked about how to find the values when you see an inverse trig function apply on a trig function. So this is what happens when you see the inverse trig function is the outside function and the inner function is the trig function. You kind of need to draw the graph, right, of the trig functions, and then the inverse trig function, the x of the inverse trig function corresponds to the y of the trig functions. So you can use it to find the values. And we mentioned about the reference angle. So and then I make this worksheet. Not worksheets, the notes, so you can better understand the reference angle. Okay. So this session is very important because in the chapter 9, session 9.5, we will solve equations involving trig expressions. Okay, so yeah, so this part is very important. And the reference angle formula sheets I posted on the website. Week 7, next to the 8.3 notes with answers. So you can click that. If you lose it, then you can look at these files. Again, what is reference angle? That's the angle made between the terminal side of the angle and the x-axis, right? In quadrant 1, our reference angle, the t prime, equals to the angle t, right, everybody? And in quadrant 2, we have, t prime is now here. The angle made with the terminal side and the x-axis, right? And you realize that the reference angle is always an acute angle. What is acute angle? Less than 0 to 90 degrees, right? Acute angle. So second quadrant, you see the t plus t prime equals pi. Do you all see that, everybody? And then the third quadrant, can you see the t? The t is pi plus t pi. Yeah, t is pi plus t prime, right? And the last quadrant, you see t plus t prime together is 2 pi, right? Do you still remember those from the chapter 7? So that is what we learned before. Now, how about the trig graphs? Can we see the reference angle in the trig graphs? Let's look at the sine function. You know, sine and cosine, they are wave. right? Sine and cosine, they are waves. And sine start with 0. And cosine start with 1. Exactly. And the first quadrant is 0 to pi over 2. Yeah? Second quadrant is pi over 2 to pi. And then the third quadrant, pi to 3 pi over 2. Yes, everybody? And then the fourth quadrant, 3 pi over 2 to 2 pi. Yes, everybody? So those are the quadrants. Now, where is the reference angle? Okay, reference angle is in the first quadrant. Okay, it's the angle made with the terminal side and the x-axis. So let's say this part, theta, is the reference angle. Okay, if this is theta, and do you look at the corresponding y values? Yeah, you draw it. And do you see an intersect graph in the second quadrant? Can you see that from this picture? Then what is this angle? Reference angle is this length, this small piece. Do you see this orange in your paper? Something wrong with the printer, it becomes red color. So it's this little piece is the reference angle. And do you see this is pi? And this little piece is theta. Therefore, this angle is pi minus theta. Does this make sense, everybody? Like second quadrant. Do you see our reference angle is T prime, right? Here I use theta. So the angle is pi minus theta. Okay? And how about, okay, this is the y value, right? If we look at the negative y value but the same magnitude, and we draw the horizontal line, do you see it intersects the graph in the third and fourth quadrants? Yes. What is that angle? Ooh, do you see this little piece is theta, right? And this point is what? Pi plus theta. Can you see from the picture? Yes. How about this point? This is 2 pi. And this piece is theta. So this angle is, 2 pi minus theta. And you can see from our unit circle. Here, third quadrant, the angle is pi plus the reference angle. Match with our answer. How about here? The fourth quadrant. We have the angle is 2 pi minus the reference angle. That's 6. So this is the unit circle, and that is our reference angle in the trig graph. Is that okay, everybody? You can actually see the picture. The little length is the reference angle. It's an acute angle. So it's really short. It's between 0 and pi over 2. Okay? And then you can find all the other corresponding angle in the different quadrants. Furthermore, look at the picture. Do you see, this is theta, and this is the sine theta. Do you see the y value is the same as sine of this angle, pi minus theta? Yes, can you see that, everybody? So we have sine pi minus theta equals sine theta. Okay, everybody? Yeah, you see the formula from the picture. So picture is like our foundation. You know the picture, then you can see everything in the picture. How about this two angles? Do you see the sine pi plus theta equals sine 2 pi minus theta? And what's the y value? It's negative of the sine theta. Can you see from the picture, everybody? So this is the pi plus theta. This is the 2 pi minus theta. Look at the y value. The y value is negative of the sine theta. So you can see this from the picture. Okay, thank you. Everybody okay with the sine graph? Similarly, we use this idea, then we can know all the other trig functions. Cosine graph. What's theta? The reference angle here, right, everybody? And how about this part? This is what? Pi minus theta. Yeah? This is pi, and this is theta, so you have smaller than that. So pi minus theta. How about here? Pi plus theta. How about here? 2 pi minus theta. You can see all the information on the graph. Now, let's see. This is cosine theta, and it's the same as cosine 2 pi minus theta. Do you see that, everybody? Look at the same magnitude, but negative. Ooh, do you see those two angles? So we have the cosine pi minus theta and the cosine pi plus theta. They are both negative, right? They are negative of the cosine theta. Okay, everybody? So draw the picture. Do you need to memorize this? No. Look at the picture. The picture will tell you. Okay? I don't memorize this formula. Okay? Look at the picture. The picture will tell you. And you know sine and cosine, they are 2 pi periodic. Right? Everybody? Yes. So that's why this table is so important, because it tells you the special angle values in the first quadrant. Once you know the first quadrant, then you can reduce the formula and know the values for the other quadrants. Okay? And you know the sine, cosine, they are 2 pi periodic. So any angle outside of 2 pi, you can add constant multiple of 2 pi or subtract constant multiple of 2 pi. So you get the range is from 0 to 2 pi. Then you look at which quadrants and play with that. Okay, everybody? Next, tangent. So tangent, this little width is the reference angle theta, right, everybody? And then do you see this is the negative theta, right? It's negative. Look at the tangent values. Because it's a function, we know tangent negative theta equals negative tangent of theta, right? Do you see from the picture? And because tangent, thank you, is pi periodic, what does that mean? The tangent of pi plus theta is tangent of theta. The tangent of pi minus theta is tangent of negative theta, which is negative of tangent theta. Right? Anybody? How about the next period? You see, the 2 pi plus theta also corresponds to the theta. The 2 pi minus theta also corresponds to the negative theta. Is that okay, everybody? If you understand, raise your hand. Do you all understand? Okay, good. Last one. Cotangent. Now, our little theta is right here. Okay? Then what is this guy? Yeah, pi minus theta. Do you see the angle are the cotangent values are negative, right? So cotangent of pi minus theta equals negative cotangent theta. And because cotangent is also pi periodic, what is cotangent pi plus theta? It will be the same as cotangent theta, right? And how about the cotangent 2 pi minus theta? It is the same as this guy, Or you can draw another piece here, and then you will see this is also negative of cotangent theta. Is that clear, everybody? Yeah. This is the reference angles in different trig graphs. And when you see secant and cosecant, you can relate it to sine and cosine, right? Secant is 1 over cosine, yeah? Cosecant is 1 over sine, exactly. Okay, everybody? So if I say, oh, secant x equals 2, that means cosine x is 1/2. Yes, everybody? So that's why we don't need to draw the graph of secant and cosecant. Just those 4 graphs are enough. Okay, good. So I hope the student didn't come to class today can watch the recording because this is very important. All right, so let's continue. So this is what happened when you have an inverse trig function outside of a trig function inside. You draw the graph, okay? How about the opposite? If you have an inverse trig function inside and your outside is a trig function, you use a method called draw a triangle. Do you still remember problem number 5? We draw the triangle. Okay, let's do the same thing for number 6. Okay, so when you see inverse trig function inside and the outside is a trig functions, you always draw a triangle. Okay, and you don't need to worry about the trig graphs. Okay, draw the triangle. So let's draw the triangle. Okay, this is the same method works for all types of this type of problem. Okay. All right. So we draw it, and you know the inner function. That's the angle theta. Okay. So you get theta is arctangent of 2. Well, that means tangent theta is 2. Is that okay, everybody? You apply tangent on both sides, and then tangent of arctangent is 2. And then you get tangent theta is 2. Because they are inverse function. Right, everybody? Okay, what is tangent in terms of opposite adjacent hypotenuse? Yes, it's 2 over 1, and it's opposite over adjacent. Yes, everybody? Mm-hmm. Oh, it means what's the opposite? Opposite is 2. What's the adjacent? 1. Oh, how do you find the hypotenuse? Square root. So hypotenuse is the square root of the opposite square plus the adjacent square. Yes, because the hypotenuse is the longest side. Longest side is the square root of the other 2 sides square at the top, right? But compared to problem 5, we know the hypotenuse and opposite. When you find the adjacent, it's the square root of the hypotenuse square minus the opposite square. Yes, everybody? Are you okay with the Pythagorean theorem part? Mm-hmm. Okay, and now we have opposites is 2 square plus adjacent 1 square. What is the answer? Yeah, square root of 5. Okay, good. Now, what are we looking for? Yeah, we're looking for sine theta. And sine theta is in terms of opposite adjacent hypotenuse. What over what? Yes, opposite over hypotenuse. So far so good? Yeah, the method is the same for all types of these problems. When you have inverse trig function inside and your outside is a trig function. Just draw the triangle. Okay, what is opposite? 2. What's hypotenuse? Square root of 5. Yes, that's it. Is that okay, everybody? Okay, good. Yes, so just remember the method of drawing triangle. And do not need to remember this. Okay, do not need to memorize these. Yeah, it looks a lot. I feel dizzy when I look at it. Just draw the triangle. Okay? So just draw the triangle. You can find all this formula. Okay, everybody? Don't need to memorize them. Okay, so let's see. Okay, because we already do like 2 problems and we don't have much time, so I will let you to do this problem at home. Is that okay, everybody? Use the same method. And I would like to do the number 2 with you. Okay, do you see we have a variable x inside? That's okay. We use the same method. Okay, you don't have to have numbers inside. You can have variable. Use the same method. Draw a triangle. Okay, so you draw a triangle when you see the inverse function inside and the outside is a trig function. Okay, so here you let theta be the cosecant 3x over 7. What does that mean? Exactly, very good. So we know that's opposite, that's adjacent, and this is hypotenuse. What is cosecant in terms of opposite, adjacent, hypotenuse? Exactly. Cosecant is 1 over sine, right? Sine is opposite over hypotenuse. So you look at the reciprocal, which is hypotenuse over opposite. So hypotenuse is 3x. Opposite is 7. Okay? If you have a variable, it's okay. Then your hypotenuse, opposite, or adjacent you in terms of the variables. Okay, but the method is still the same. So we are looking for the adjacent. What is adjacent? Square root of opposite. Who's bigger? Is the opposite bigger or the hypotenuse bigger? Hypotenuse is bigger, right? So you use exactly. Yes, very good. And hypotenuse is 3x. 3x squared. Be careful. Don't forget the parentheses. Parentheses is like your baby. Who's your baby? Parentheses. Don't forget the parentheses. Minus opposite. What's opposite? 7 squared. Okay, what is 3 squared? 9. So we have 9x squared minus, what is 7? 49. Good. Okay. So that is adjacent. And what are we looking for? Yes, we're looking for cotangent theta. What is cotangent theta in terms of opposite, adjacent, hypotenuse? Adjacent over opposites. Good. What is adjacent? Yes. Opposites? 7. That's it. Okay? See? So we learned 2 type of problems. If you have the trig function outside and inside is a trig function, you need to draw the graphs of the trig functions. Okay? But if you have the inverse trig function inside and the outside is just a trig function, you use the method drawing a triangle. You don't need to draw the trig graphs. Okay? Yes. Any questions up to now? And I can change this cotangent. I can change cotangent to any of the trig functions. And I can change the inverse trig function to any of them. You use the same method. Okay, everybody? All right. Very good. Okay. Next, we're going to solve triangles. Okay, solve triangles. Let's look at this. Find the value of theta. Okay, so find the value of theta. What is this side compared to theta? Opposite. So this is opposite. And what is this? Adjacent. So in the exam, I will not just ask you to find the theta. I will ask you to solve the triangle. Solve the triangle means you find all the angles and find all the sides. Is that clear, everybody? Mm-hmm. So we can label some like vertex there. Let's say this is A, and this is B, and this is C. Is that okay, everybody? Yeah? Let's label some side because we need to solve all the angle and all the side. What is the side opposite to angle B? We call it small b. Yes? What is the side opposite to angle A? Small a. Yeah. And what is the side opposite to angle C? Small c. Okay. So look at the side. We know A and B. Can we find C? So A is 32. B is 23. What is C? What is C? C is hypotenuse. And what is C? Square root of A squared plus B squared. Yes, everybody? And keep exact answer. Okay, let's see. A squared is 32 square, and B squared is 23 square. And that square root, what's inside the square root? What? 1553. Thank you. You can leave it like that. So C is the square root of 1553. Is that okay, everybody? We find all the sides. Now, let's find the angle theta. Okay, we can call it angle A. The easiest, you can, because now you know all the sides, you can use any trig function. But because we already got like 32 and 23, they are integers, right? So we can use those two to figure out the angle. Opposite and adjacent. What trig function relates to them? Tangent, right? So tangent angle A is opposite over adjacent. What is opposite? 32. Adjacent? 23. Right, everybody? So now angle A is then the tangent of 32 over 23. Here, use degree mode. Okay, Everybody take out your calculator. Can you see the arctangent button? You press shift and then you press the tangent. What's arctangent of 32 over 23? And give me 4 decimal places. 2933. Thank you. Yes, everybody. This is angle A. Yep. And we know what is angle C. 90 degree. Then what is angle B? Exactly. Very good. Yep. Plug that in your calculator. 7. Thank you. Yes. So that is our answer. We solve the triangle. We find all the sides and all the triangles. I mean, all the sides and all the angles. Yes. Any questions up to now? All good? Okay, now it's your turn. Okay, so find all the angle and all the sides. Let's label them. Okay, let's call this is C, and let's call this is B, and let's call this is A. Okay, your turn. All the sides and all the It's still snowing. March. let's check our answers together. Okay, so all right, so this is side C and that's side B. We don't know A, right? So how do we find A? Square root of C squared minus B squared, right? Because the C is the hypotenuse. That's the longer one. Okay, and then we have 11 squared minus 5 squared. What's 11 squared minus 5 squared? Thank you. We get 96, right? So square root of 96. So we know all sides. You can use any trig functions. But because 11 and 5, they are good numbers, right? So what trig function do we use to find the angle A? What trig functions do you take? Cosine. So cosine A is what? Adjacent over hypotenuse. What's adjacent? 5. Hypotenuse? Good. So what's A? 60. Thank you so much. Yes. So this is the inverse cosine of 5 over 11. Right, everybody? Good. And then we know angle C is 90. Then the angle B is exactly, very good. Oh, 9643. And what is your answer? Thank you. Yes. Oh, here we can use approximately equals. Yes. So we find all the sides and all the angles. So in the exam, you will have a problem like this. Okay? Good. Now, story problems. Right? Okay. So story problems. Okay, number 5. Suppose a 13-foot ladder is leaning against a building, reaching to the bottom of a second floor window 12 feet above the ground. What angle in radians does the ladder make with the building? Okay, so let's draw the picture. We have a house, right? So we have a house, maybe like that. Okay, and we have a ladder. Okay, leaning against a building, reaching the bottom of a second floor window. Okay, let's say this is the first floor, and this is second floor window, and it's 12 feet. Second floor window is 12 feet above the ground, and then the ladder is 13 feet. Let me draw this better. Okay, so that's the picture. Yes, everybody? The 30 feet ladder is leaning against the building. The bottom of the, maybe some I want to climb up the second floor. Okay, and this is 12, and we want to find the angle in radians does the ladder make with the building. So, what are we looking for? Are we looking for this angle or that angle? The top one or the bottom? The top one. Angle makes the ladder with the building. So we are looking for this theta. And we know this is a right angle triangle. Yes, everybody? Yeah, okay. Let's see. This angle, theta, is what we're looking for. And we know the 12 and the 13. What's the 12? What's this side? Adjacent, exactly. So adjacent is 12. And what is 13? Hypotenuse. What trig function do we use? Cosine. Cosine theta is adjacent over hypotenuse. Adjacent is 12. Hypotenuse 13. Because so theta is inverse cosine of 12 over 13. Make sure you're in the radian mode because the problems ask you to find the radian. Okay? Use your calculator, change to radian mode, and then inverse a cosine of 12 over 13. What do you get? Or 7. Okay, thank you. What's the next digit? Yes, if the next digit is greater or equal to 5, then we round up. Good. So this is the answer. Any questions about this problem? So we're going to read the story and draw the picture. All right. Okay, good. So everybody finished problem 5? Okay, let's look at 6. Truss for the roof of a house is constructed from 2 identical right triangles. Each have a base of 12 feet and height 4 feet. Find the measure of the acute angle adjacent to the 4 foot side. Okay, we draw a picture. So we have this, and we know this is 4, and then this is 12, and this is also 12. And then we have these triangles. They're identical. Find the angle, measure of the acute angle adjacent to the 4 foot side. So we're looking for this. Let me put the 4 next here. Okay, so we're looking for theta. Everybody okay with the picture? Okay, so we have 2 right triangles, but we just need to look at one of them, right? We don't need to look at both of them. Look at the left part. So this is the angle theta. What is the 4? Adjacent. What is the 12? Opposite. Which trig function? Tangent. Is that okay, everybody? Yep. Tangent theta is what? Opposite over adjacent. Opposite is 12. Adjacent? 4. What is 12 over 4? 3. Yep, good. That's 3. And now theta equals arctangent of 3. Okay. Let's also use radian mode. What is arctangent of 3? 1.2490. Oh, okay, good. Yes. So yeah, put the 0 there, then I know it's 4 decimal places. Good. Okay, so any question about number 6? Oh, good. Okay, now you do number 7. Let me try number 7. All right, let's check our answers. So we have horizontal distance, 100 feet. Rise, 7 feet. We're looking for the angle made with the horizontal. So what is 7? Opposites. What is 100? Adjacent. What trig function do you use? Tangent is opposites over adjacent. 7 over 100. So tangent of 7 over 100 is, thank you. Do you have the same answer, everybody? Good. So this is sessions 8.3. Now we've finished chapter 8. Your exam next Monday will be about chapter 8. So do your homework. Homework 8.3 and the quiz 3 is on Wednesday. And then work on the practice exams. Questions? What? You need an answer for those? Yeah. Oh, it's on the website. So it's on the website, and then yes, this is a practice exam 2 solution, and this is the answer on the website. Yes, here with answers is the answers. Yeah, make sure you're familiar with the formula sheets. Okay. If you haven't like fill those out in class, come to my office and fill it out. Yes. Have a nice day.